Hey everybody, how's it going? It's Dr. Jensen for CCJ 3701 Research Methods in Criminology. We are here to do bivariate statistics. And this looks really scary and intimidating, but it's not. It's actually really easy. And I'm going to pretend you forgot everything about this stuff in any stats class you ever had. And I'm usually right. So if you've noticed by now in the class, I treat this more like a workshop, like a skills training class where we get to jump into data and start working on stuff, and I prompt you through steps. That's the most successful way I've found to teach it, and people do pretty well with that. But again, reach out if for any reason something's not working, and I can make some adjustments. I'm happy to do it. I like making data a lot of fun. It should be. It's very creative, and hopefully you've been able to settle in pretty well by this week in the class. So we're going to learn about bivariate statistics. Last week, hopefully you got a chance to see my little Powtoon video that showed univariate, bivariate, and multivariate statistics, just basically having one, two, or three or more variables. So depending on how many variables you have, what's inside those variables, how they're measured, and what you want to know, that'll help you know what to run. But we're going to go over that too. So I'm back here in Turlington Hall and ready to share with you crosstab and chi-square. So we're going to do that procedure, statistical procedure, as well as talk about statistical versus substantive significance. So this is something you kind of saw at the end of the last lab. You know, what does she mean by that? What the heck is that? Statistical is the numbers that get spit out of SPSS. Those are all your statistics. And then the substantive significance is basically, what does it mean in English? So you're going to have to get good at doing that. Any data that any employer or program gives you, you have to be able to write it up in some kind of report that someone can use and understand and make decisions with it. That's the whole point of statistics. So, you know, anyone can practice running them, but it's interpreting them where the real action is. And we're going to do this a lot and get good at it. Okay? So, just by way of background, statistics techniques when determining what statistic to use, and you're examining the relationship between two or more variables, you have to look at the nature of both variables to know what you can run on it, because it has different properties, and there are certain tests that have requirements that need to be met, and it's going to look for data with those certain properties to see if it'll work, okay, because there's different little mathematical requirements. So that is level of measurement, nominal, ordinal, interval ratio. We're going to talk about that again. And we got to look at the distribution of the data, again, if it's normal or not, discrete or continuous. We got to look at both that for the predictor variable, also known as the independent, and the outcome variable, also known as the dependent. So that way we know what to run. That's basically a statistics truth in a nutshell. I would have paid thousands of dollars if one professor would have just told me that. You got to know how the data are measured. You got to know how they're distributed, how many you have. If you know those things, you're going to know what to run every time. And you do. Once you practice it, you get really good at it. But nobody would ever tell me that. They'd take me through some stupid math proof that felt like algebra, and I got really lost. And that's why I hated stats. So now I learned the stats truths, and I got a lot better at it. So I really boil things down to just that. I'm not going to take you through some mathematical proof. That is just not useful for what we're trying to accomplish. So the chart on the following slide is a little guide that I made up. This is kind of a basic chart, but it works for our purposes. So on kind of the left side, you see dependent variable, outcome. On the right, you see independent variable, predictor. Okay, and then you see nominal, ordinal, interval ratio. Nominal, ordinal, interval ratio. Well, you just follow the rows and columns together, and where they meet in these little boxes, these are the kinds of statistics that are possible if you have variables that are organized like that, okay, that have those properties. So if I have a nominal dependent variable and a nominal independent variable, I can run a crosstab, I can run a chi-square, or I can run a lambda test. Now, if I have an interval ratio, that's IR, dependent variable, something that's a number, and I have a nominal independent variable, a category, I can run a t-test or I can run an ANOVA. Okay, so these are just lots of different kinds of tests that can be run depending on how your data are organized. So that's why it matters to really know what you have. And I'll ask often before you work on a variable, what kind of variable is this? What's in here? Is this numerical data? Is it kind of like a rank ordered piece of data, higher or lower, more or less, or is it just strictly categories? When you know that stuff, you're going to know what to run. Okay, I have another little chart that's all fancy schmancy for the multivariate relationships. And this gets really kind of crazy. I'm not going to go through this in detail, but for those of you headed to grad school, this is a good one to hang on to when you're doing a really heavy duty kinds of testing and stuff. So same kind of a thing. Here's the predictor variable, the independent outcome variable across the right for the dependent. And it'll ask you a little bit more, about not only is it a categorical piece of information, how many categories does it have, what kinds of things you're trying to find out. So again, just kind of reference for the future. So the common procedure we'll do in class is the crosstab and the chi-square. I kind of grade them in this chart so you could see them. That means that our variables, whether they're dependent or independent, are all going to be nominal or ordinal. They're going to be categories or little categories you can rank in order. That's it, okay? Sometimes we treat an interval variable as though it's like a category, and you can do that. We don't do it very often, but you can. All right. So again, you'll always want to begin looking at your measures you've selected. So we always review and become familiar with variables we're about to do stats on, because you never test or analyze what you don't know. You run your frequencies, you run crosstabs, you look over the code book, you familiarize yourself with the value labels and how the question was asked or how you got the data, what field it came from or what it represents. And then you ask yourself if it's sufficient for what you had in mind. You may find that there are other variables out there that might be better. So again, this is kind of where you have to kind of do your shopping for your variables. Okay, now then. So in crosstabs, here's a famous crosstab from sociology. So we have two variables. One is called how often do you attend church? And the other one is called what is your gender? Okay, so basically these sociologists wanted to test the idea that someone's gender predicts how often they go to church. Okay, they thought that there might be something to this, so they actually got some data on everyone's gender and everyone's church attendance, and they did a crosstab. Okay, so check this out. So across the top, in the columns is gender, men and women, and then across the rows is how often they went to church. Okay, that's very common. You might want to make a little note of this, to put the independent variable, gender, across the columns, and then you put the dependent variable, how often you go to church or church attendance, in the rows. Okay, that's more of a common format. You don't have to do that. Some people prefer to do it in other ways so that the formatting of the table is a little bit better for them. Totally up to you, but that's the most common way to do it. So we look at this and we just report, do you go weekly? Do you go less often? They have kind of weekly, monthly, yearly, never. So that is an ordinal variable, because not only is it a category of how often you go to church, but it's also basically, we can rank them, right? The people that go weekly go more than the people that go monthly, and the monthly people go more than the people who go yearly. So we can do kind of the more or less, higher or lower attendance, right? So that's why it's a little more than a category. You can order it. Now gender, are you male or female? That's a nominal, right? We don't order it and put one above the other. It's just what group are you in, this or that. Okay, and you can have multiple groups as well. So things like gender and race, maybe position, those kind of things are definitely categories. You don't usually put things like higher or lower. It's just this or that. So in this crosstab, it spit it out, and we look at it at a glance and we go, okay, well, we have 100 men and 100 women, and it does appear that more women are going weekly than men that are going weekly, but when we're observing it, we wouldn't know for certain. It looks that way, but are we right? We're not really sure. And so a chi-square test that accompanies your crosstab is going to tell you whether you can count on that result over and over again and if it's actually true. So what appears to be going on in the table is one thing. Is it true statistically? That's another. Or is it really just kind of a circumstance that happened in this data set? It lets us know that. Okay, so let's go back just by way of review. The kinds of variables that are in this table, you can run a crosstab and chi-square test on two nominals and do a nominal-nominal. You can do a nominal-ordinal, an ordinal-nominal, or two ordinals. So what do these all have in common? They're basically all categories, okay? And they only provide certain answers. You answer this, 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 or this, and that's it. Okay, so it's pretty exhaustive into just this or this, and that's all you can give. So basically a chi-square test just tests your category membership over here, being able to predict your category membership over here. That's it. That's chi-square in a nutshell. Okay? So chi-square tests the hypothesis in a crosstab that the row and column variables are independent. So chi-square assumes that these two things have nothing to do with each other. Knowing your gender really has nothing to do with how often you go to church. Okay, so we call that the null hypothesis. Okay, so we always assume it doesn't work, or there's no relationship, or there's no association. And then we run the test and we see if we are proven wrong. Okay, that's called the alternative hypothesis, or what we call the research hypothesis. So we assume these things don't matter until we test it and it proves that it does. That's it. So the question in a chi-square is what I observe, what I expected. So when we make a prediction, we say, I predict that these two things have nothing to do with each other. So if I were to go back to this little chart, I would see equal numbers or roughly equal numbers in all the boxes. 50, 50, 50, 50, 100, 100. Really, these two things have nothing to do with each other. They should be pretty equally distributed across all the little boxes, and it won't matter. Okay? So we want to know if when we go observe and go collect data on it, if that's actually true. Is this relationship, or in this case a chi-square association, significant or beyond chance that it occurred? Okay, so chi-square is a very basic statistic. It does not indicate the strength or the direction of the relationship, how it goes, in what manner, but it tells you if there is one there, if these two things have anything to do with each other. And it's kind of fun to run. You can say, are these associated together? Okay, you don't say correlated, you say associated. Okay, here's another example of chi-square. So here we have some medical data. We have the reason for your visit. Okay, so this is patients at a hospital. They have 1, 2, 3, 4, 5. These are just little numbers that represent a category of information. So 1 is I was at a follow-up or a visit. Number 2 was a routine checkup. Monitoring a chronic condition is number 3. Acute visits. Checking up on an acute episode. A pre-surgery visit. A flu shot. So it gives lots of categories as to why someone might go to the doctor. Okay, and then over here we have gender, male, female, and they just use zeros and ones in this case to represent those categories. So we'd want to maybe look and say, does knowing someone's gender, their category membership in this nominal variable, let us predict, the kind of visit they're going to go to the doctor for? So you could ask, are men or women going for certain kinds of visits? Is there some category that they tend to go for more than the other? And so that's kind of basically the research question. So we basically plot it all out in this little table, and we start looking at these numbers, and we look at these percents, and we look for the patterns. What are we seeing here? With men and women going to the doctor, we can see that just a little bit more women tend to go for acute visits and chronic condition monitoring. And fewer women actually go for regular checkups. Actually, more men go for regular checkups. So it's kind of interesting what you find. In here's just some detail. We want to know, are the differences between the groups bigger than what we would expect based on chance alone? Is this just circumstance that the numbers landed this way, or is there really something going on here between knowing this about you and letting me predict that about you? Maybe they have nothing to do with each other, but we won't know unless we test it. That's why we do statistics. So we assume they don't have anything to do with each other until we're proven wrong. We go, actually, there is something to do with gender and going to the doctor. Okay? Or maybe there isn't. That's why we run the test. Welcome to science. It's okay to be wrong. So if we run that crosstab, you also get a chi-square packaged with it. In SPSS, you have to select a little checkbox in the statistics tab, and it shows you the chi-square statistic. So in our next lecture, I'm going to show you what this means and how to interpret it. But this is the significance level. Doesn't look like much now, but in the next lecture, it'll tell you a lot. We'll see you then.